Hello guys, now I'm going to discuss another complex problem of modeling and simulation, that is reliability problem. So problem statement states that like a milling machine has three different bearings that fall in surface. So distribution of the life of each bearing is identical. When bearing fails, a mill stop, a repair person is called and new bearing is installed. So it further says that delay time of repair persons arriving at milling machine is also a random variable having the distribution given. So distribution is given. Downtime for mile is estimated as $10 per minute. Okay, and other such things is given. I will relevant such things is given. Now I'm going to just uh, questions. So bearing life distribution is given like this is the bearing life and the respective probabilities is given, and delay time distribution is also given like delay time is 5, 10 and 15, the respective probabilities are given. So here delays random digit is also given. And now the first step we have to bearing so random number for 1, 2 and 3 bearings also given. So for bearing 1 these are the random number, bearing 2 these are the random number, and bearing 3 these are the random number. So this is our problem statement. Now we have to simulate these things. So for the first step we have to first find out the bearing life distribution and their respective random digit assignment. So for bearing life, this one respective probabilities is given. So cumulative probability will be for 1 is 0.1. So random digit allocation is 0 to 10. So for second one it will be 0.1 plus 0.113. So it will be 0.23. So random digit allocation will be 11 to 23. Accordingly we can calculate this. And now I am going to next step. Here delay time distribution given, so we can find out delay time distribution. Here delay time is given 5, 10, 15, respective probabilities is given, cumulative probability we can calculate here. And now we have to assign random digit accordingly 1 to 6 and 7 to 9. Accordingly we can do this. Is a very simple step. Now the third and most important step here is this. So now we have to simulate bearing. Okay, so here for bearing 1 this I have calculated this one, and for bearing 2 I have calculated this one, for bearing 3 this one calculated. Then first time failure, so random digit accordingly and according to that delay. So for bearing 1, as the random digit is given, already given in the question, so for random digit 67 we have to go in bearing distribution table, and we have to find out that what is the lifetime duration of this one. So for 67, so 67 lies in this range. So this is the respective of 1400 bearing life. So we have to mention here 1400 horse. Accordingly for 8 it will be, for 8 will be live in 1000 bearing life horse. Okay, so 8 lies in this section. And for 49, so 49 is lies in this section, so 1300. Okay, so 1300. Okay, accordingly we can calculate for bearing 1. Okay, so for bearing 2, so we have again look the random number, and accordingly we have to write their life horse. And for bearing 3 we have to do the same thing. And now first time failure occurs, we have to calculate this one. Okay, so for this, so for first time failure we have to take minimum of life hours for bearing 1, 2 and 3. So minimum of 1, 2 and 3 we have to take here. So first time failure occur here 1400, 1400, 1500. So minimum is 1400. For this one 1000 and 1200 and 1400. So minimum is 1000. Okay, so for third one it is 1300 and 1700 and 1300. So minimum is 1300. Okay, accordingly we can calculate here. Now random digit for delay is given in the question paper. As we can see here, random digit for delay is given here. Now we have to mention here random digit for delay. Okay, so now when the random digit for delay is 3, so we have to go distribution table of delay and have to see that random digit 3 lies in which range. Okay, so delay distribution table is we have to see here. Okay, so for 3 is lies in this range. Okay, first one, so the respective delay time is 5. So delay time is 5. Now for random digit 5, we have to see that it lies in which range. Okay, 5 lies in this one range, so delay time is 5, this one. Now when the random digit is 7, again we have to go in our respective table. So when random digit is 7, so it is lies in delay time this section, so the delay time is 10. Okay, here is 10 is mentioned. Accordingly we can calculate this table. Now we have this table. Okay, so we have to now first add the first failure occur in all our simulation table. So we have to find out this one, summation of this one, and summation of delay time this one. So we will get value like this one. Okay, now we also have to actually we also have to find out some numerical values according to our question. So for that we have to use these numbers, these values, and accordingly we have to proceed. So as in question it is given that cost of this bearing is dollar 32 per hour, and for delay time or downtime it is $10 per minute, or repair person is this one. Okay, so it take 20 minutes to change one bearing, 30 minutes to change 2 bearing, and 40 minutes to change 3 bearing. It is given in the question. Now we have to calculate actually cost of bearing, total cost of bearing. So for this we have to find out number of bearing multiplied with 8. So we how many times simulation is performed here? 1 2 3 4 7 6 7 8. So 8. And cost of one bearing, so when we multiply with this one we will get cost of bearing. Okay, so $768. Okay, now cost of delay time we have to calculate total delay multiplied by cost of delay. So 55 minutes multiplied with $10, so we will get $550 here. Okay, so cost of downtime we can calculate total simulation into number of bearing multiplied with change time for one bearing into rupees 10. So we $10. Okay, so we will get $4,800 here. Okay, and now we accordingly we can calculate cost of machine repair person. So here, so as the total simulation is 8 and number of bearing is 3, and we have to multiply it with 20. And now as for this is given, cost of repair person is given $30 per hour, so we have to convert it in minute. So we have to divide by 60, and we will left with this value, and accordingly total cost we have to find out actually in our question. So for this one, cost of bearing we have to add with cost of delay and cost of downtime delay plus cost of machine. So we will get add all these values, we will get this one $6358. And now total life of all the bearing we have to calculate. So here the total summation for first failure is this one, so we have to multiply it this value with 3, so we will get this value. Okay, now the total cost per 10,000 bearing horse. So as we get total cost this one. Okay, and now when we divide this value by this value, we will get this value. Okay, so this is how we can perform simulation in bearing problem. So this is a standard problem in modeling and simulation. So hope that this is helpful for you. So thank you very much. Bye bye.